Now let's go to the next part of our lesson and let's create a little bit different type of tornado. So I think I will keep bottom, remove white. I think we don't need a debris. So I leave some of those elements. Let's save it. Let's call this tornado wide version 1. And so the thing is, I just think I will delete this branch. I will keep just 2 of those. I want to create a wide, huge tornado, the large scale tornado near the ground. So that's why I will use my alt script, but I need to change something inside of it. And here's my curve. Let me put it here. And I guess that I want to create just a straight line without any kind of animation, all this stuff. So I will disable all those guys here. So bypass. And I don't have a group, so I don't need to delete it. So now I have just a straight line. I will keep this line in the case if you want to create some kind of animation. So if you want to add a movement for this line, so we still have tornado curve and go to tornado noise. That was important, and we begin with this size. I guess that we have a by default the tubes with size like 10, and I guess I will keep this. Anyway, I will create the same tornado scale, but I can just then put this tornado closer to camera or make a bigger size with transforming the cache files. So we have a blast, all these guys, so scatter. I will keep my scatter, I guess, with the same amount of points. So my noise is 0.4. And yeah, I will keep this, the blast. So the first thing I think I want to change here is definitely my vortex force. I need to play with this to create a very huge, small moving tornado. I mean, the slow speed, because we have a very big range, very big radius. Therefore, the rotation speed will be slower, but basically the particle speed will be the same. Okay, so with the same particle speed, we will have a big radius. So therefore, my tornado will rotate a little bit slower. So to do this, I can remove this pop wind, I can remove pop kill, I guess, by the moment, or I can leave it in the case if my particles rise up very fast. And let's go. And well, I want to add the pop drag node. So I will slow down my particles, and maybe I'll play with this, just paste 0.1 like we did. All right, so with the noise, well, actually, let's begin with forces. It's more important because I want to create the shape, and then, well, in fact, to create this shape, what I want to is just reduce the attraction multiplier, so it will create a bigger radius. It won't attract, all right, too much. And now you can see that we have a very large, large radius simulation. Now let's leave it 101. Let's go to like, I don't want to use a big random, so I will keep it like 0 and 1. Now with the noise, let's change amplitude to 10 and go raw, because by default set it. So yeah, it's more like, I'd want to create a big noise at this stage, actually, at this stage. And Houdini crashed, but it won't stop us. So let's go and let's change something here. Let me just see. Yeah, I'm gonna have the same amount there. because I load the autosave project. So with an object ramp, orbit ramp, let's go to 1 with the bigger orbit in upper. So okay, with an attraction, and with attraction I want to have very small attraction amount in the bottom area, because I want to create like a wide extend in here, and like 0.2 maybe for the last, and in the middle somewhere 0.6, 0.3, something like that, and 0.6 maybe, 0.45, 7. Yes, we have something like increasing the attraction, so it will create like a curve, so it will have more forces going to the center in the middle of my curve. Let's change it to cut more room, make it more smooth, like a feather. And the up force ramp, I guess, let's set like 0.75 in the end. So I don't want to have a very big speed. Yeah. All right, it's still going somewhere very far away from this. So I definitely don't need those particles. All right, so I can remove them, and yeah, I add another camera. I call it cam2. I don't know why, but I just copy existing camera, and therefore the picture from the camera transfers that. But this is what I want to have. This is my vortex. And let me just change this. Oops, come on. Analytic parallel noise. So it will have a bigger noise. Changing. Now let's go to the source first input, and I'll increase the amount of particles to let's say 200,000, and with some life expectancy set to 3 seconds plus minus 1. So somewhere in frame 75 they begin to die. I don't want to write them too far away from here. And Houdini say hello again with some errors. But we keep going. What I want to do here, basically, if you look at our tornado, it's rising up. So what I can do, I really want to set him in more random a little bit. So 0.75. It's looking more interesting. And what else I want to do, if you go to our forces, we have the traction multiplier, which is 1 by now. So it doesn't change anything from this, from this subtraction. So what I want to do, I want to take the ramp. So now we have a traction just to our line. So we create a vector going from each point to the middle of to the center of this rotation, to the points on the line we created. So what if I add the fit range and then said that I want to drag my 0 to -1. So now I will have a range between -1 and 1, which just means that I will have negative and positive values. So we will attract our particles outside. We will move them outside. And we have a lot of noise. Another thing I want to change here, actually I want to play with some drag. So we have 0.1, and beginning from frame, I don't know, maybe from frame 100, those points fly away, and I already have like a shape Let it wait a little bit. 104. Should be soon. So yeah, definitely should kill those particles. So enable my pop kill. And maybe even make this pop kill even lower here. Oh, we'll remove them anyway. Okay. Let's go to frame 100 and set a keyframe for the air resistance, and go to frame 120. Can stop simulation and set it to 1. So now, beginning from frame 100, I will slow down my particles. So I already have some, like a mesh created, and then I will slow down particles to create a bigger resistance. I don't want to have such a huge rotation. I will slow down my particles. Take some time for doing that, and now begin from frame 100, means slower and slower and slower and slower and slower. Okay, so those particles will die, which is good. So I don't need to remove them, they will die anyway. And this is my shape. That's how it's looking. That's pretty nice. So I keep this noise as it was, and I don't need to pop kill. Let's go to the camera view. Yeah, you can see that we're losing some points over there and out of the camera range. So before we go further, I want to remove my pop wind. I will remove the pop kill. But what I want to add is the pop property to set a mass for my particles, just a random mass. Go to mass, use expression. So by default, I leave it 1, but I want to set a mass multiply by some fit of 1, so here fit of 1, because I want to fit my range with a random value. So random by ptnum, and I want to fit like 0.75 and I know 1.5. So which means that I randomly create a mass attribute for each particle. By default, this mass attribute is will be from 0 to 1, because that's our random default values range. But I fit this range, I change it from 0 to 0.75 and from 1 to 1.5. So now my minimum mass is 0.75 and maximum closer to 1.5. And if I want to use this mass, I need to disable the ignore mass check button here. All right, and now let's save those particles. So again, with the attribute delete and the group delete, I will remove unused attributes and groups, just one group and a lot of different attributes. So I will keep the ID, color, age, all those guys, but I should rename, I don't know, like wide particles. Okay, and cache those particles. So I have 500 frames. Let's change it to 300, because I will retime this simulation, I guess. So it will be enough just 300 particles. So I've done the cache. Now you can see it's white particles, $F. And I have a shift to 240. I guess that I will shift it to 120. As you remember, I used the drag animation from 100 to 120. So beginning in 120 frame, my drag is 1. So I will back to the same frame, 120. Okay, let's see. I want to see a dynamic for my, I don't like 120 frames, it should be enough. I will make like 100 frames render, and as I think a rotation a little bit faster than I expect, because for such a huge simulation it's a little bit faster. But anyway, you can play with this if you want to create a very fast tornado. We can play with the settings, but I prefer to create more massive result, and therefore I will change the speed for those particles. So we can go by a few ways. We can have a few options. The first thing, you play with the speed of my particles inside of the pop network. Or we can use the drag option, increase it even more to slow down those particles more. Or we can slow down at this stage when we have a cache. So let's do this. Let's stop it. And after the time shift node, let's go and set a time blend node. And with the time blend node, I choose the by speed, which just means I can change my speed playback, and I change it to 0.5, so 2 times slower. So now if I press play, it's moving 2 times slower. But it's what more important is, if you want to use the velocities, and we will use velocities, you can see that it's changing the speed simulation, not simulation, speed playback cache, but it doesn't change the velocity size. So if you want to do this, you need to enable the scale velocities, because I want to have a less velocity because I have 2 times smaller speed, and we can use velocity when interpolating position. So it's not too much influence on this case, but velocity is very important stuff, because if we have a slower movement but the same velocity, movement is not so important for us, but we're going to use velocity to rasterize this for our pyro simulation. So this stage is very important. All right, so now I create even bigger frame range. So using this, we can even make less cache. But anyway, we have 300 cache, so minus 120 for the time shift. We left 180, and now we have multiplied by 2. We have 360 frames. That's more than enough for even a long shot. So particles out. Now we're going to use the pyro source. But what I else can do here, before I go to the pyro source, I definitely, after all those things like changing velocities, sometimes you can find that those velocity can be a little bit incorrect. So what I want to do, I want to change the velocity using the trail sub. It was here, but I remove it. So I use the trail and compute velocity. So now program will find the direction where our particle was and where it will be in the next frame. And yeah, I need to match by attribute. So we now try to find a movement for each particle. So using the particle ID, the trail sub tries to find where our particle is moving, and based on this information, it will draw the velocity vector. And we're going to use this velocity vector. And now, as we did, we use a pyro source for creating the density, and then the attribute noise for adding some noise here. So let me just remove this and this, just bypass, not remove, by bypass. So when I see my, oh, that's my mesh. So maybe I increase the particle size maybe to 2 to have a better result. Let me remove velocity to have just the density, view the density. And we can add, go to my camera and enable velocity blur. So if we switch to frame somewhere like 76, we will add just a tiny bit of blur. Should be fine. Now with an attribute noise, let's see what we have here. And here density animated, let's go to the simplex. simplex. Here we go. So maybe -1, and I'm gonna keep the same settings just with element size a little bit bigger because I really want to have a big noise. Okay, the big size, the big scale of my vortex, and the bigger element I want to add here. So all of this thing is by default, maybe like lecurity 1.5 and set to minimum. All other stuff I want to use by default. So additive mode, 1D density. That's what we have. Then I want to remove the attribute wrangle and enable the point velocity. So let's see what velocity I have there. Not you. Okay, so with the curl noise, I definitely should have a bigger swirl size because 1 is too small. I'm gonna leave the scale is 5 and duration is 2, but increase the swirl size maybe like 7. So it won't create a very low scale velocities, low scale noise. And I will leave this as it is. So when I rasterize density and velocity, don't forget about that because I remove sometimes velocity from the attributes because when I see just density, velocity is not very visual represented here. It's looking weird. Okay, so our density now go to the vortex seam. And there's gonna be my vortex wide seam. And as you can see, by default, rename it in the DOP import field. Let's go to the setup, go to the fast frame, and smoke object sparse. And I don't need that. I don't think that I need a sparse mode, so let's go to the all good pyrosolver. And the smoke object. Connect this guy and this guy. So as always, we need to find, or actually no, I don't want to grab all density from here because there is some, there is a lot of density under the camera view, so I don't want to see this. Anyway, I will remove it. So let's go and create a bounding box around my simulation. How we can use it more? Okay, let me just use our source size from the smoke object. So it's first input. Okay, so I have a size. Oh no, because it's a smoke source. Let me just choose this name and put it here. So now we have the size. So for the y-axis, what I want to do, I want to minus it. So minus 20, and for the centroid, minus, let's copy this. Anyway, okay, let's minus 20 then, minus 10. Okay, so maybe even more, minus 30. So here's 15. Yeah, something like that. So we save some space. And I don't need to use the gas size fluid dynamic, or we can add this because sometimes it can be helpful. But I will set that I don't want to, I will enforce boundaries by -1 and +y, -y and +y. I will keep this stuff here. Okay. Or even just, clamp to maximum bounds, and that's it. By default, leave this, guys. Now, with the smoke source, what I want to put here, how many smoke do I have? I have a 0.7 maybe a little bit less, like 0.5, and velocity, which is 3, so maybe like 5, set 5 scale, because I have a pretty small vectors, but length. So with simulation, I guess that I should add a little bit of sub-steps, so just increase it by 3 maximum, and maybe for the final simulation I will add 2 as a minimum sub-steps. Do need to enable combustion, and for this kind of simulation I want to have a buoyancy leaf too big, because my smoke is moving more like a horizontal, in a horizontal direction. It's not moving up too much, and I want to use a viscosity. It's just one of, I know, 1 per 100 scenes when I use the viscosity. So I will add the viscosity to make this smoke more like a flowing look, as they call this. So go to shape. This last one I want to change here. Definitely need to have a bigger dissipation, like 0.5. I don't want to create a smoke leaking from the vortex and moving somewhere, so I will remove this. And I want to add a sharpening for the smoke. Another thing which is we don't have by default in the sparse. Yeah, we can add like a microsolver, and maybe some disturbance. And let's add a disturbance like 5. I mean, 5 is too much. Maybe 2. 2 can be good, and with the disturbance a little bit bigger block size, 0.4, because we have a big scale for the sim. So let me add, yeah, voxel size. What is the voxel size? 0.2. Let's say 0.1, and let's say 0.15 maybe, just to see how detailed this thing will be. Vortex white seam smoke, yeah. So let's simulate a few frames, and I will see. Let me just enable simulation first frame. Come on. And you. Solid creation frames. Why is creations here? I don't know. The properties here, creation there. I just accidentally move this or what? That's interesting. Okay. Now we have this, and wow, it's looking not bad. So let's add a flipbook. Before I go into the file cache, I want to simulate a few frames with voxel size 0.15. So make a pause. Let's wait a few frames to see what do we need to refine here, change maybe something. So I calculate 10 frames. So disturbance working, but I definitely should add more turbulence here. So because it's rotating, but it's pretty static. So what is the common thing that I want to fix here is that our noise inside of the DOP network, I mean, when I said a noise, I mean my turbulence and disturbance, it's static. Yeah, it's animating, so it's have some pulse lengths, but our smoke is rotating and the turbulence stay at the same position. So we can fake it by rotating the cache we will calculate. So I add a turbulence, and I definitely need to add a little bit more, come on, decent time, a little bit more turbulence to have an effect for moving smoke. So swirl size, let's add a big swirl size, like 10 meters. So it's like a huge, there's like here a big swirl size. With the grain is maybe 8, and very, very small pulse lengths. They're very small. I mean, again, when you think about that, very big pulse lengths to have a very small speed, changing speed, or the noise speed. So I press 10, it almost is static. But our smoke is moving from this static noise. All right. So let's decrease the division size to 0.1, and I will calculate this simulation. Let me change the minimum substeps to 2 because we have a pretty small speed. But I want to have a more accurate result from simulation, so let's increase the minimum substeps to 2. So it doesn't matter what speed we have, the minimum substeps we will use as a 2, and for the fast parts we will use 3 substeps. Okay, let's press escape and let's go up here. Let's rename it vertex wide 1, can call this, and let's save it to max. I'm gonna leave my S1 out version, and after let's simulate like 100 frames. I will explain why just 100. It will take less time for simulating and less disk space, but maybe I will slow down the simulation, make some rotation to get a proper result for me. So let's start theming, and we will see what we can do with this cache for rendering.